All right, I'm going to make a video to get you ready to take the 2.7, 2.8 quiz. My advice would be, as you're going through this video, take some notes so that you can have those ready for the quiz. And then I would say pretty shortly after watching this video, I would go take the quiz so that you're not having a lot of time between reviewing it and then actually doing it, since everything's going to be done while you're at home with us. So the quiz is over two sections, 2.7 and 2.8. 2.7 are all about absolute value graphs. And what you should notice about absolute value graphs is you should know that they all look like V's. So every graph we're talking about, it looks like a V. It either is right side up or upside down, depending on if it's positive or negative in the beginning. You should understand how these graphs shift and then how to draw and recognize graphs of them. So biggest thing I'm going to focus on in this review video is talking about that shifting, those changes that happen. So if you look at this first one, first thing I notice is there's a -2 in front. What that -2 does is it flips it upside down or creates a reflection over the x-axis is another way to think of it. The next thing I notice is in the absolute value bars, when you have a minus with the x in the absolute value bars, that's going to move it to the right that many spaces. So this one's going to go right. And when I have a minus after the absolute value, that's going to move it down. So that's the first kind of descriptive part of this is I know that it's been flipped upside down. I know it moves to the right. I know it moves down. So on my graph, I'm going to go to right three spaces, and then down 2 spaces. I'm going to put a point. That is my vertex point. Next thing I'm going to realize is because it's upside down, I want to make sure when I draw it upside down. Because the slope has a slope of 2 or -2, we want to think of it as going down and then over. So when I draw it, I'm going to go down to right 1, down to left 1, and I get this V graph that looks like this. We would say that it's a little more narrow because of the 2 that's in front. It kind of steepens that slope and makes it more narrow. But then we have my vertex, which I'm going to write down, is the 0.3, -2. My axis of symmetry is always x equals whatever your x value is. That's the line that splits it equally. I'm not going to talk a ton about domain and range in the quiz, but I do want to mention that your domain for every absolute value is always all real numbers because it goes forever to the left and forever to the right. Your range is limited though, and this is something that will help you if you're working on that optional quizzes. Your range, it goes down forever, so -infinity, but then it never gets higher than the vertex. The vertex is at the height of -2. So the way I'd write my range, I'm going to do it down here because I have more space, is it's going to go from -infinity and then it's going to stop when it gets to a height of -2 because that's the highest the graph ever gets. So that's your first one. Second one has shifting of it's going to go 2 to the right. It's going to go up 5 because of the -2 inside the absolute value is what shifts it to the right. The +5 at the end is going to shift it up. All the 3 is going to do is it's going to give it a very steep slope, but it's still going to be upwards. So on my graph, I'm going to go over 2 to the right and 5 up. 1, 2, 3, 4, 5, and put a point. There's my vertex. My slope is 3, so it's pretty steep. I'm going to go up 3, right 1. It's going to be kind of off my graph here. And then I'm going to go up 3, left 1. And I get this skinny, upwards facing V graph. My vertex ends up at 2, 5. My axis of symmetry is just x equals 2. My domain, again, is all real numbers. My range, you'll notice for this one, the lowest it gets is a height of 5, and then it just keeps getting bigger and bigger and bigger when you're talking about your y values, your heights. So this is going to go from 5 to infinity. Again, biggest takeaway that you should have from this is the shifting and how that changes the picture, because that's what you're going to be quizzed over. There's also ones where it asks you to not draw it, but just to kind of describe that shifting and what that does to the vertex. So what I noticed with this one is this is going to move it to the left 5 spaces because it has a +5 in the absolute value. And this is going to move it up 3 places. So if I go left 5 and up 3, that's my vertex. Left 5, up 3 from the origin ends up at a vertex of -5, 3. The 1/2, all that does is it's going to make it wider. It's the slope, but it's still going to be pointed upward. And my axis of symmetry is just going to be x equals -5. For the second one, this is going to flip it upside down. So that's going to have that reflection when you have a negative. It doesn't go right or left at all. So you're going to stay at 0 for your vertex, but it is going to go up 3 because of the +3 at the end. So my vertex for this one is 0, 3. 0 because it didn't go right or left at all. 3 because it went up 3. It does flip upside down. So when you draw it, if you just want to think of it like what a sketch would look like, it would look like this. It's pretty narrow. And my axis of symmetry is at x equals 0. So that's a recap of everything you did in 2.7 with drawing graphs, recognizing graphs, finding the vertex of these absolute value graphs. 2.8, the focus in 2.8 is to graph linear inequalities. So I want to show you one in slope-intercept form. I want to show you one in standard form. And then I want to show you a couple where the graph's already provided and you have to figure out the inequality. So for number 9, it's in slope-intercept form. So I'm just going to make some notes here. My slope is -2/5, which tells me I'm going to go down 2, right 5. My y-intercept is at the point 0, -1. So on my graph, I'm going to go to 0, -1. So on the y-axis, down 1 space. And then from there, I'm going to go down 2 spaces, right 5 spaces. So down 2 spaces, right 1, 2, 3, 4, 5. And those 2 points are going to help me draw my boundary line. You're going to look at your inequality. So if you look at your inequality, because it has an equal to, you want to draw it as a solid boundary line. And then your shading, because y is by itself, because it's in slope-intercept form, a less than means you're going to shade underneath. So the nice thing on Delta Math is you can just click the shading and switch it. If it's under and you want it to be above, you can just keep clicking the button and get it to where you want. So that's my graph of the first one. If it's in slope-intercept form, what you're going to do is you're going to do the cover-up method to find the x-intercept and the y-intercept. So if I cover up the y's, I'm going to get 4x equals 8. Again, I can just think of it as the equals because I'm getting the boundary line. So my x-intercept is 2, or 2, 0. And then I'm going to do the same thing with y. -2y equals 8. Divide by -2. I get -4. So my y-intercept is 0, -4. So on my graph, I'm going to go 2 on the x-axis and put a point. And then I'm going to go 4 on the y-axis and put -4. So it'll be down 4 on my y-axis and put a point. This is going to be another solid line because it has the or equal to. So I'm going to draw a solid boundary line. Now, finally, for the shading, when it is in standard form instead of slope-intercept form, the best way to figure out the shading is use the 0, 0 test point. So if I test 0, 0, it's going to make everything on the left side of this inequality 0, and I need to figure out if 0 is greater than or equal to 8. 0 is definitely not greater than or equal to 8. So I do not want to shade the side of the line that includes the origin, that includes 0, 0. So I want to shade the side that doesn't have 0, 0, which would be this side. And there again, you can kind of toggle between your shading. You can toggle between the types of lines in Delta Math. Finally, the last thing you're going to be asked to do is, given a linear inequality graph, given a boundary line equation, see if you can write the correct inequality. So the first thing you want to do is you want to look at the line and you want to see, is it solid or dotted, and where is it shaded? So if you look at this first example, it is a solid line and it is shaded above. So what that tells me is that it has to be solid, has to have the equal to, above has to be greater than, it has to be a greater than or equal to. Again, because it's solid, that's where the equal to comes from, and because it's above, it's a greater than. And then I'm just going to write in my equation for the line, which was given. They're going to tell you that, and that gives you my inequality. For the next one, now we're going to notice that it's a dotted boundary line, and I'm shaded below. Dotted boundary line means it's going to not have the equal to. Below means it's going to be a less than. So my correct in linear inequality would be y is less than, and then we're going to fill in, based on knowing the boundary line equation, x minus 2. That is everything you need to know to be successful on the quiz. So hopefully you jotted down some notes, maybe went back and wrote a few things down, and you are ready to go on to Delta Math and take the 12-question quiz.